Hello guys, so for this problem I want to find for which t I'm going to get horizontal and vertical tangent line. So first let's find the derivative of my parametric function. So for that, what do I need to do? I need to find the derivative of y corresponding to t over the derivative of x corresponding to t. Or in other words, is 2t cubed plus 3t squared plus 1 prime over 2t cubed plus 3t squared minus 12t prime. So what I'm going to get, on the top I will obtain 6t squared plus 6t, and on the bottom I'm going to have 6t squared plus 6t minus 12. And if I'm going to factor 6t on the top, I will get 6t times t plus 1, and when I'm going to factor 6 on the bottom, I will get t squared plus t minus 12. And you can see that we can cancel out t. And then another thing what I can do, I have a t squared plus t minus 12 on the bottom, which is a quadratic equation. And since the root of the quadratic equations are 3 and negative 4, I can factor the quadratic equation as t minus 3 times t plus 4. Then for next step, what do we need to do? We need to take our derivative and we need to figure out and remind ourselves what does it mean that something, that our tangent line is either horizontal or vertical. So we have dy over dx is equal to t times t plus 1 over t minus 3 times t plus 4. And let's take a look at the top. And we know that if we have that our derivative is equal to 0, then it means our tangent line is going to be parallel to x-axis, since our dy over dx is going to be just f prime of x, which is a slope. So in other words, our slope is equal to 0. So that's why if we want to find horizontal tangent lines, we need to find t such that my derivative is going to be equal to 0. Okay, but if we're going to take at the bottom part, then what we're going to obtain? In that case, if we're going to have that something over 0, then in that case our slope is going to be infinite. Or in other words, if we can imagine that we have some sort of parametric graph, then there's going to be a point where our tangent line is going to be parallel to y-axis. You can think about that if we have our tangent line is parallel to x-axis, we have that the top part is equal to 0, and then if our tangent line is going to parallel to y-axis, our bottom part is going to be equal to 0. Why? Because we can just interchange y and x, and you will get that we have function x in terms of y. So we're going to find the slope of the function when y is changing and how fast is our x is going to change. So in other words, if we want to find the vertical tangent line, we need to set the bottom part of our derivatives to be equal to 0 and find for which t that works. Finally, our last step, let's find for which t we have horizontal and vertical tangent line. So you can see that if we have t times t plus 1 is equal to 0, then we're going to have t is equal to 0 and t is equal to negative 1. So for those t, we're going to have horizontal tangent lines. And for the bottom part, we have t minus 3 times t minus plus 4 is equal to 0. So we have t is equal to 3 and t is equal to negative 4. So for those t, we're going to have vertical tangent lines. Okay guys, thank you for watching. If you enjoyed this video, please like, and if you're not subscribed to my channel, please like and subscribe, and have a nice day. Bye.